RoboBlox, the main driver, I believe it's demystifying the use of robotic technologies and focusing on the potential of mass customization and the way we interact with it. So following the initial driver, we focus on this idea of open artworks, or OLIPO. It was a French movement where they used, for literature and mathematical purposes, they used a rule-based strategy in order to compose poems or narratives. In architectural terms, what we tried to combine was appropriate the idea of the brick. And the brick has been extensively used through Victorian times until modern architecture, where it was more creatively used in order to create new forms. Subsequently to that, there was this specific brick which is perforated, called the breeze block, which allows light and air flow, and also creates this sort of transparency within the facades or wherever the walls there might be used. We appropriated this idea of the breeze blocks and actually took it one step further in trying to combine mass customized forms, different forms that could actually be designed and combined by the user themselves. So this was one outcome of trying to evolve the design of the brick. We took on this idea and propelled it further to be mass customized and tried to have a direct interface between the user and the design of that pattern or that wall. Versus the initial of the 20th century, where mass production was the key driver in industry, we are now at the turn of the century again, where mass customization is becoming the main driver, where everything can be customized to the user's needs. The user has total control or some control to produce his own tiles in this case, and through that production, the methodology of that production being appropriated through robots and their flexibility. So this is where the name was generated, RoboBlox. So it's blocks fabricated by robots, but designed by the user. So what we did, we set up a structure, a rule-based structure based on the Morpholo game that was invented in the 1970s by Thierry Foucault, where there's a grid and where edges must combine with other edges in order to proceed and build a similar organic form. The special aspect about the Morpholo game is that departs from a code that generates combinatorial sequences. In each square, tiles can be arranged in different ways. This simple instruction creates many different combinations without interfering with the center of the tiles. The only rule of the game is to match empty edges with empty edges and full edges or with full edges. By transposing the Morpholo game to a three-dimensional matrix, tiles become blocks and space becomes the medium. In this case, by adopting the same rule on combinatorial...
You make a robotic fabrication technique like hot wire cutting, which is what we've been using here, really accessible to people, so you don't need to actually have access to the robot. If you can get to a web page, you can go and create your own little composition that will then be cut on the robot. So I think that's pretty cool.
So the 3D modeling software for architects, that is called Rhino, has a visual programming language, which is basically certain components connecting to one another through wiring systems. And this visual programming allows architects or designers to be able to program in a more efficient way. It's a different language, basically. In our Grasshopper program, what we are doing is we are taking the curves that are defined in the web interface as a front side of a panel and then the back side of a panel, and then creating a loft in between these two elements, so the front and the back, which creates these in-between lofts in the two curves. After that, there is a component in the grasshopper that communicates with the robot itself by defining the midpoint of these blocks and aligning the end effector of the robot, which is a hot wire cutter, to certain target points. And then the robot follows these target points to basically cut the curves in the styrofoam material. Industrial robotic arms are now being used in creating custom-made artworks or 3D.
The reason that we used one at the end of a 6-axis robot is because we had the agility and the precision that we normally wouldn't have with a human hand, and so we could get accurate blocks out of the foam every single time with every single cut.
So the hot wire cutter, when it's entering to the material, it's releasing certain fumes. So we have to do this process in a workshop setting. That's why we used University of Queensland KUKA robotic arms and the engineering and architecture IT faculties robotic arms to cut these pieces. The cutted pieces are then brought into the workshop spaces in Queensland University of Technology, where we drilled holes in both directions of the blocks so that they could be weaved into a big net of a frieze type of a sculptural piece, where it gives the flexibility of motion as well as creating these light and shadow effects in the artwork. And the pattern that we chose to explore is the pattern of the Brisbane River, where it feeds itself on the motion of the Brisbane River that has carved through centuries into the river bed. And that's what we are looking into as part of Brisbane Art and Design. As part of BAD, we also have an interactive game of RoboBlox where the users can come and try to achieve a pattern, a predefined pattern that is made of these 3D printed blocks that they can move around and explore the possibilities of the game. So the basic rule is the edge conditions should match, so that they can move the pieces around to find out what's the actual pattern that we have created for this art piece.